In this video, we're going to learn about the periodic table. We'll learn about how the elements are arranged on the periodic table and how we can figure out what types of properties elements have based on where they're found on the periodic table. Now, fun fact about the periodic table. Before 1867, when Dmitri Mendeleev arranged the elements in the periodic table form that we know, elements used to be grouped by their alphabetical name. So anytime a new element was discovered, you had to create an entirely new periodic table, which was kind of tedious. And also, there was no apparent rhyme or reason with the elements because they didn't have any similar properties. They were just ranked by their alphabetical name. And then Mendeleev noticed something. He took all the elements and he put them on cards and wrote down all the properties about them. And he started to arrange them based on their atomic mass, which helped him figure out that there was a bit of a pattern. So as he arranged the elements along the way, he would discover that there was a repeating pattern. So anytime the pattern repeated itself, he started a new row. And that's how we ended up with this shape of periodic table. And we now understand why there was this pattern. First of all, we'll talk about the metals. So elements can be a metal or a non-metal. And the metals are found on the left-hand side of the periodic table, aside from hydrogen. Hydrogen's special. And you can see here I've colored them in orange. And metals are shiny, they're malleable, they're conductive, they conduct heat and electricity, and all of the elements except for one are solids. The one metal that is not solid is this one right here. Its symbol is Hg, and that's mercury. And mercury is actually liquid at room temperature. All the other metals are solid at room temperature. The nonmetals are found on the right-hand side of the periodic table, so right here in blue. And then hydrogen being special is also blue because it's not a metal. And these properties are that they are dull, they're non-malleable, so if they're a solid, they'll be brittle. They don't conduct heat and electricity, and they can be found in all three states. So some are solids, some are liquids, and some are gases. Now, metalloids can't really make up their mind. So they're found on what we sometimes say is the staircase between metals and nonmetals. There's almost like a little staircase, jaggedy line here that divides the metals from the nonmetals. And metalloids, like I said, can't make up their mind. So they have some properties of metals and some properties of nonmetals. So we take silicone as an example. That's this guy right here, Si. It's shiny and it's semiconductive and it's silvery, but it's brittle. So it breaks if you try to hammer it out into a sheet. Groups are vertical columns in the periodic table. So groups run this way. And members of a group have similar properties. So everything within a column would all be, reactive or non-reactive or have other similar properties. A period is a horizontal row. So it goes this way. And there's a pattern in how elements act or behave as you move across a period. So if we start here, this group is very reactive, then it's not quite as reactive and a little bit less reactive, and then as it goes this way, it gets more and more reactive and really, really reactive again, and then the noble gases aren't reactive at all. And then you'd start all over again, being really reactive and so on. So alkali metals are found in the first group. So right here in the part that I colored red, the very first group. Their physical properties is that they're shiny, they're soft, they're silvery, and they're malleable. Their chemical properties is they're very reactive in air and water. So they'll actually react with the water vapor in air, or if you drop a piece of alkali metal into a beaker of water, it will ignite or even explode. And alkali metals all have one electron in their outer ring. Alkaline earth metals are in the second group. So we've highlighted that one here as the orange column. So right here. And their physical properties is that they are shiny, they are silvery, they're soft, and they're malleable. And the chemical properties is they're reactive in water, but not as reactive as the alkali metals. And the number of electrons in their outer ring is 2. Halogens are in the second last column, so the second last group, also known as group 17. And the physical properties is that they are, they can be solid, liquid, or gas. And the chemical properties is that they're very reactive. And the number of electrons in their outer ring is 7. The noble gases are found in the last group, also known as group 18. Their physical properties is that they are colorless gases. Their chemical properties is that they're not reactive. And the number of electrons in their outer ring is 8, or for helium, 2. Because helium only has 2 electrons total, so it has a full ring. All of them have full outer rings, so that's why they're not reactive at all. Now, as you can see here, I've colored other parts of the periodic table to show other sections or properties. So, like I said before, these are the alkali metals. These are the alkaline earth metals. The nonmetals are here in blue and purple here because I've colored the groups as well. So if you have here, these are the nonmetals, and we don't describe that group. These are the halogens. These are the noble gases. This yellow section here is known as the transition metals. These are some more metals, and remember, these 2 groups are metals as well. And then down here are metals as well. And these are known as the lanthanides and actinides. And then remember this last part here, the kind of staircase part, are the metalloids. So that is the periodic table.